Example 3.3. So what it says here is that an explorer is caught in a whiteout in which the snow is so thick that the ground cannot be distinguished from the sky. While returning to base camp, he was supposed to travel due north for 5.6 kilometers, but when the snow clears, he discovers that he actually traveled 7.8 kilometers at 50 degrees north of east. Sketch the vector diagram of the motion and then how far and in which direction must he now travel to reach base camp. So note that when I'm looking at this picture, I don't know if you guys have ever been in a whiteout. They're pretty damn scary. I hope you guys are never into that situation. What we want to do here is that we want to draw a picture here. Now note, when you first draw the picture, you gotta realize that your picture may not be exactly right. Okay? And so we're drawing a figurative picture. It's the mathematical picture that's going to give us the right answer. But when we're kind of sketching this, we have to sort of like be aware of what's actually happening here. So let's look at this thing here. So I'm going to set up my coordinate system again. So I'm going to start with my physical picture. And so when I'm looking at my physical picture, I'm seeing something like this. So it says here, he was traveling. So he was supposed to travel due north for 5.6 kilometers. Okay. So in other words, he had a resultant that he was trying to do. His goal, let's say, is to travel this length right here. And of course, even though I didn't write this here, here's my coordinate system. So this guy, since we've been calling the resultant D here, I'm going to say that this is my vector D, where the vector D is the resultant of two paths. But what he finds out here is that when the snow clears, he actually traveled 7.8 kilometers. So note that when you're looking at the length of D here, we could see that in his, let me move this over just a little bit. We see that D has a length of what? 5.6 kilometers, and his angle is 90 degrees. That's what this person wanted to do here. But note, he travels much farther than the 5.6 kilometers. He actually travels at 50 degrees. Let's say that this is 50 degrees. He overshoots it, but at an angle. So we're going to say here that this is going to be path A. And what do we know about path A? Well, it says that it has a magnitude of 7.8 kilometers, but its angle is north of east. And we should be really careful with our language here. So let's be careful. What do we mean by north of due east? So when I look at my axes, the first one tells you essentially the direction that you're going. The second term is telling you relative to what. So if this is east, that means if you go north of east, that means you're traveling in that direction here. You're traveling in the north direction relative to east. I've seen a lot of people make, I don't want to say silly mistakes, but mistakes when they're actually, because they're confused. Does that mean north of east? Does that mean I go east of north? No, it means you go north of east, and it tells you that it's going to go north of east by how much? 50 degrees. Okay? So in this case here, it's 50 degrees north of east. So then it says he wakes up, or the snow clears up. It's pretty spooky to try to walk out in a whiteout situation. Hopefully this dude spent the night there. And then what happens here is that he knows that he's off track. So what does he do? He has to go back and he has to walk another path to get back to where he has to go. So I'm going to call that path B. So what is the question? The question is, how far and in which direction must he now travel to reach base camp? So our goal here is to find the vector B here. But there's some nice things about this vector here, right? The nice things about this picture here is that we can clearly see that if D is the resultant here, it must be that in order to get to D, we had to do what? We had to go by A, and then to get to D, we had to take another path. And so now that's our resultant here. So if we want to solve for what path we had to take along B, then what we can do here is that we can solve for B. And if we solve for B, we could see then that B is really what? D minus A. So our goal here is to actually calculate D minus A. So let's go do that here. But what's our picture here? Okay. What is our mathematical picture? We could keep it right here, right? We could keep it right here. But what you're seeing here is that look at, so now if I go to the mathematical picture, we want to take all our vectors and we want to put them at our tails at the origin. So let's go do that. So here we go. So what do we know here? Well, we know D, right? We know D. So D is going where? It's going up like this. So we know everything about D. So we're not interested in A, we're interested in minus A. In other words, what we want is we want D plus minus A. So what is minus A? So then minus A, if this is A here, we got to do a reflection. So minus A goes like this here. So if that's minus A, then what we do then to get D is that we need to then do the parallelogram rule. Now, I'm going to put that right at the origin here. So I think what I'm going to do here is that since this is much longer, I'm going to make this just a little bit longer so that I get below the axis. Okay, there's minus A, so now I'm going to do the parallelogram rule. So the parallelogram rule says I'm going to go up 3, and then I'm going to connect these. So what is the direction of D? It goes like this. So B looks like this. Our whole goal is to calculate B. So let's go calculate this thing. So what do I know about the angles here? If this angle here is 50 degrees, then I know that this angle here is 50 degrees. So then let's go do our mathematical calculation now. So that's the picture that we want to deal with, is the mathematical one. So I got to get, so my job here is that I got to look at these vectors. So I have the vector D. When I look at the vector D, you could see that it only has a component along the y-axis. Its x component is 0. So in other words, when I look at D, I have dx, dy, but I see that it only has a vertical component, so I know that that guy is 0. And the full length of this guy is 7.8. So no, is it? No, it's 5.6. So then this is 5.6 kilometers. Okay, so we're set here. So I know both of those components. Let's go look at the vector minus a. So remember what I'm doing. I could start with the vector a, or I could deal with the vector minus a. So let's go look at the vector a. So when I look at the vector a, I know that I need these components here. So remember, if I measure from the positive x-axis, what I'm really getting is the magnitude of that vector. So let's go get the magnitude of that vector. So what I'm going to do here is that I'm going to get the magnitudes and then add the signs by hand. So let's go do that. So I know that the length of AX is then AX is going to be A, in this case, cosine of 50 degrees, right? Because I know that I could pick any quadrant that I want, and then I'm going to do that. So if I get that, then this is going to be what? It's going to be 7.8 kilometers cosine of 50. And then I'm going to get that this is 5.01 kilometers. So this component tells me that that's the magnitude. So what I'm finding then, I need to add the sign. So when I look at my vector, note that this guy is where? It's in the third quadrant. So I have to come in and put my sign in. So this tells me that AX is then what? 5.01. But because it's in the third quadrant, I put a minus sign. Then I do the exact same thing for AY. So then I'm going to get AY, which will be A sine of 50. So then I'm going to get 7.8 sine of 50. What's the length of this vector? 5.98 kilometers. Which quadrant is that vector in? The third quadrant. So therefore, the sign tells me that I have that magnitude, but because it's in the third quadrant, I'm going to put my sign in here. So now I have what? I have my A negative AY. So now my job here is to add negative vector AX, AY to the components of D here. So let's go look at that. So here we go. So now what I just created here is that the resultant D hat is then going to be, it's going to be B plus, did I do this right? No, I did not do right. It's not the resultant B is then going to be what? It's going to be D plus this minus A. This guy is minus A. So now I'm going to add these. So D is then going to, of course, be dx plus minus AX, dy plus minus AY. So then here I go. I know that D has 0. Minus X is then going to be minus 5.01. And then when I look at dy, I know that's 5.6. And then this guy's going to be minus 5.98 kilometers. So if I add these quantities up here, I'm going to get minus 5.01, and the other one's going to be minus 0.38 kilometers, and that's what the vector B looks like. So now I have my vector B. So what am I going to do? I'm going to go in, and I'm going to get the angles here. So if I look at this thing, the magnitude and the angle. So here I go. The magnitude of B is then going to be, of course, bx squared, by squared, square root. So in other words, this is going to be minus 5.01 squared plus minus 0.38 squared, square root, and I get a value that reads 5.0 kilometers for the magnitude of B. Let's go get the angle here. I get the angle here, and I'm going to get tan inverse of by, bx. Now plugging in my values, this is tan inverse. Look at the minus signs, right? I really have minus 0.38, minus 5.01. So right away, we should be paying attention and going like, wait a minute, those signs tells me it's in the third quadrant. So what angle do I get? The angle that I get here is 4.3 degrees. This is not in the first quadrant. This is in the third quadrant. What does this angle of theta B mean here? So let me go do this here. So when I look at this thing, I then draw my axes. And what do I know? Well, we know this is already in the third quadrant. So when I look at this vector, it looks like what? Well, it's going to be like this. What's the length of this vector? It's 5.0 kilometers. But what about the angle? Well, the angle, 4.3 then, is measured where? Relative to the negative x-axis, which is going to be what? 4.3 degrees. And this is my vector B. And that's the right way. Now, there's lots of ways that we should look at this thing here. So remember, we should state this angle is measured relative to negative x-axis. On the quiz on Tuesday of next week, if you give me an angle and you don't tell me where you're measuring it from, I'm going to deduct points immediately. So you gotta always stress. And what you'll find here is that textbooks give you different directions of how, or different ways of doing this. So check this out. This is north, south, east, west. So how else could I have defined the angle? Well, we already talked about this guy being plus 4.3 degrees. Or I could have measured this guy from where? The positive x-axis. So in this case, we could have come in here and we could have said, yeah, oh yeah, that's 180 plus 4.3 degrees. So it's really this angle. And of course, we say here, this is from measured from positive x-axis. Both of those answers are totally legit. Another very common here is that we can do this here. Well, look at where we're measuring from. We could have also said that our angle is what? It is 4.3 degrees, but where am I measuring from 4.3 degrees from? From the west axis. If this is from the west Ooh, I think my mouth is getting dry. Look at the direction that I'm moving. I'm moving in which direction to go there? In the south. So then this is going to be, look at the language that we used before. The language that we used before, up here, it says what? North of due east. So in this case, we could then say this is south of due west. Or we could write this shorthand and write south of west. And that's a totally legit thing. And some questions are really horrendous. And look at this. We could have also given the angle relative to here. And if I give the angle relative to here, let's say I measure this from the south axis. How do I get to this angle? Which direction do I got to go? I got to go west. So if you look at this thing, the angle is then going to be, we know that this is a right angle, so this should be 90 degrees minus 4.3 degrees is going to give me what? 85.7 degrees. So I could have given the angle D as what? 85.7 degrees. And how do I go? I'm going in which direction? West of due south. In other words, I can write this as 85.7 west of south. And that's a totally legit way of actually writing the angle down. I think we're getting carried away with the angle. All I wanted to do is I wanted to make sure that you had a chance to see all of the possible angles.